Hello and welcome to another episode of Invalid Entry. My name's James Taylor. I got a comment on a previous video. It happens all the time, but this one was interesting because there's some promise behind it, some techniques which people may not have seen. And it's quite short. It says, I wonder if a submodule's code can change a main function's variable. It's an interesting statement here, which the answer, because this was on a Python import lib video, I assume this question is for Python, but it actually applies to other languages as well. The answer is yes, but usually that's a terrible idea. But I thought I'd show how that works. It's actually inbuilt into most languages. Even if it wasn't fundamentally because of the way how computers work, you effectively are looking at another area's bit of memory which maybe you don't have a direct reference to. Or even an indirect reference to, you can usually generate some kind of force it through the system. So the more basic languages like C or assembler, you can just pick random numbers and just go to those locations in memory. In more constrained languages, and even in C#, when you move into unmanaged mode, you can do that. In Python and things like Java, it can still be done. There are usually ways to do it, and the reason for that is to do with reflection and exception handling. So in certain situations, you want to look at the stack. So in Python specifically, the stack is what they call frames. There are a series of frames. Each frame is a frame of reference, which shows you what your current locals are. So if I do x equals 3 or 4, then I can do locals like that to get back everything which is currently in scope. And because I'm in Jupyter Notebook, I've got tons of stuff in scope, like underscores and all kinds of stuff, which this is a brand new notebook, so there isn't a lot here. It is worth noticing, because I'm in a Jupyter Notebook, I'm not actually in the main thread. Now, I want to say main function was the original thing. There isn't really a main function, because there is just the executing script file, which can act as the main function, but really it's just a block of code. So it's worth knowing that not everything has to be in a function in Python. Just like in other languages, something like Java, everything has to be a method on a class. Even main is a method on the class. You'll say, I want to execute that class as my main class. Whereas in Python, that isn't true. You can just have code, and that code can be in a function, or it can just be code, just code. Okay. The other question is submodules, but really modules and functions are almost the same. I'm going to get onto a video at some point about what a file in Python actually is and how it actually executes code when it's loaded. But anyway, I'm going to import sys, because sys is the system library. The next thing I'm going to do here is a little bit, people may go, oh, you're not supposed to do that, and you're not supposed to do that, but we're going to do it. So I'm going to do sys._getFrame. I'm going to pass a number. I'm going to pass naught in. Now, naught means my current frame. If you're thinking about the stack going upwards, naught says get the current frame. And you can say the reason why you shouldn't do it is because it's got an underscore. Underscore generally means it's a private function on the sys module, and therefore I shouldn't be calling it. If you look up the documentation for it over here in sys, you'll find there's all these random things like current frames. Get frame will be in here, the display hook. Here we go. This becomes implementation specific, and by implementation I mean the interpreter, the Python interpreter using, in this case, Python, or IronPython, or something else which you're using. Now, you should only use it for internals and specialized purposes only. This is a very polite way of saying it's not for you. Okay, these functions can have very weird side effects. But that basically gives me a frame pointer. So I can say current frame equals sys.getFrame. Okay, and then current frame, if I dir it, you'll see it's got a whole bunch of things in there. It's got a thing called f.locals. It's also got fcode as well. You can actually get the code to the currently executing frame, which means you can get the stack pointer, a stack trace on. You can actually manipulate these things to say, when I return, I don't want to return to where I was returning, I want to return to a bit further on. So you can actually jump instructions on the previous thing. You can do all kinds of, you can actually replace the code of the module you're calling. It's not the right way of replacing the code of the module you're calling, and it's also going to have some very weird side effects if you use it in bad cases. So that's the current frame, and I can now do .locals. In fact, flocals is a dictionary, so I can do f.flocals. I'm going to print on there, and I'm going to print the x value, So you can see there that current frame is currently expired. That's not very interesting at all because obviously I've exited in scope. So I can make a function. I'm going to do the same thing, or parent frame equals sys.getFrame minus 1. So I'm going to go 1 frame down. I always put minus there, but that would be bad. And then do parent frame dot f locals x equals 4, 5, whatever. So I'm going to do x equals 4, foo, print x. You can see there, x in the parent scope, i.e. the scope of this, has now been set to 5 by this. So I've actually modified a variable in the parent caller. To go all the way back to the root, you just basically want to go all the way to the top of the stack. This is a stack. You can basically count the number of frames that there are. There are functions for that. And you can manipulate variables in the parent scope. You can also look at things like self. So if it's an object, you can say, actually, is there a variable called self? And therefore, what's the type of that? Is the object that is calling me a type that I like? Where's it defined? What's its code defined? The rest of it. You might be tempted to think you can make real private variable functions out of methods. So you could write something where it goes class bar def foo self, like that. And then you could do parent frame is, have I gone behind my, I've gone behind my screen. Let me scroll down, move over a little bit. There we go. Get the parent frame, and you can say that what is the type of self in the parent's locals, and therefore you can have def bar my door blowing open, and you can do just something simple here. Just call foo self dot foo if the type equals type bar even. Yay. Nay. Look at that mismatching quote marks and everything. So b equals bar. We're going to do b dot foo, call it illegally. Ooh. Did I do that wrong? Did I do that wrong? Yeah, self. Doesn't have a self variable. Yeah, that's fine. That is correct, because obviously the current room does not have a self. So I could say if self in. This is what happens when you write code. And there you go. Nay, and I can do b dot bar, call it correctly. But it still goes nay for some reason. Yay! Right, okay, so that took a bit longer than I thought because I put the quote marks around that in the wrong place. So basically it's saying, yes, this is now being called from a subfunction var. Now, there's a whole bunch of reasons why this is terrible. The first thing is, if I knew a function was doing this, I could escape this quite easily. There are various tricks I could use to cause this to not work. There's various tricks I could use this to make sure that inheritance was working correctly. It's not a good idea. If you need to write language in a way which has force protection of locals, you should change language you're writing. Python is not the language for this kind of programming. But the point is, you can access the stack. Now, this is actually accessed in a whole bunch of standard places. One of the best places I can think of it, I'm just trying to open up an image of this now, is the Django debugger screen. So what you see here is a screen like this, where actually it's looked at the stack and it's actually pulled out all the local variables of each of the stack traces. So when you try to debug what happened, the exception stack itself goes, yeah, I'm going to loop over the stack, get all your variables, be able to print them off. Need to be a bit careful in those situations. You've got passwords and things in there. A good debugger will actually mask those things as well. But as you can see here, there are various over the years debuggers and things that are going to happen. So yeah, this is where you're on the stack. This is your Python path and so on. Give you access to all the information you need to diagnose what's going on. But that's it. In a nutshell, you can indeed access parent frames. You can modify them. You can do what you like with them. You can modify your parent's code as well. You can modify your parent's pointer, the return pointer. Generally, it's a bad idea because what you've done is you've actually coupled the function that is being called to the function. As you see here, when I did this wrong, was I didn't have it correct, so my code just fell over. So to make your module usable in future things. Python, by the way, has another feature which is kind of funky, which is you can make a thing return A, B, C, more than one thing. So when you say, oh, actually I want to do it because I want to set a whole bunch of variables in the parent, like some kind of weird factory, just make a factory object that returns an object. I wouldn't return lots of things. Sometimes I return 2 things at most. So I want like a status and the actual data object maybe. Or information like a timestamp or something. But generally you're better off defining a data object to return and returning a data object. I can't think of any situation where I've done this and it's been a good idea. I can't think of any situation where I've even considered setting a parent variable outside of very specific tests, security tests I've been doing, where I made a function to manipulate code. I did some work on code white boxing in Python, and I just found it was too easy to always avoid it. I was trying to avoid sideloading. I was writing code to avoid sideloading, like this kind of stuff. I just found I found more ways to avoid it, and it was very easy to spot and very easy to then realize that if you were using this sort of technique, you had something to protect. So it sort of highlighted the bits of code. So if you want to do really cool white boxing of things, you really need to be moving into C, and you need to be moving into compiler technologies which will apply it to your source code, i.e. you write in one language or C, and then it manipulates it into another layer of C, and that actually compiles down. So yeah, that is it. That is going to be a shortest video on how you can really break Python. As I say, the underscore is a giveaway that you shouldn't be doing it. If this video went over your head, it's not for you. If you understood this video and you've never seen it before, I hope you realise this is not a design pattern you should be using. I cannot stress this enough. It can be done. But if you ever see someone messing around with sys outside of a debugger context or outside of a diagnostics context, I would be suspicious of their motivations and design pattern. So yeah, have fun with that. Have fun with this knowledge. If you find a use for it that I haven't considered outside debugging, please leave me a comment. And yeah, I hope to see you all again in the next episode.